When we talk about CPUs, we often talk about cores. Well, what does a core mean? We could mean physical cores, such as on this computer. We see we have two physical cores. We have two places where we can place a CPU, two sockets. These cores may take a little bit to talk to each other because they're located on different locations. But we do have two cores, so it's faster. We have two separate CPUs processing information, processing instructions. This can become very space-consuming as well as cost-consuming in order to actually create separate cores. And again, with two separate cores, they have to transport information to other controllers across different buses, and those signals can degrade if the CPUs are too far away from where they need to send signals. So we've come up with a solution that is a bit more cost efficient, and we have the faster performance of having multiple CPUs, but we get to save ourselves some space. What this is it's called multi-core processors. One physical processor chip that acts as multiple cores. It has multiple cores in it. For example, we'll use the Intel Core 2 Duo. This one physical chip would have two cores. And these two cores can independently act as their own separate processors. So it's virtually like we have two separate processors, but we have two separate CPUs in one processor. Now, this also eliminates the issue with the signal degradation because we have both of the cores in one location. They're on the same processor. We've seen a lot of advancement with the multiple cores. We have cores that go i3, i5, or even i7 cores. And again, all of these cores, we want to remember when we're talking about multi-core processors, are one single processor with multiple cores inside of it. The next attribute of CPUs that we need to discuss is going to be hyperthreading. What is hyperthreading? Hyperthreading, first of all, we need to know is Intel proprietary. So we're only going to find it on Intel CPUs, obviously. Hyperthreading basically takes one core and it sort of allows that one core to share workload. In order to have hyperthreading, we have to have the CPU, the BIOS, and the operating system, as well as the application we're using, all have to support hyperthreading. What's the best way for us to visualize hyperthreading? Well, let's say we have our one CPU. Now, again, this is one CPU that we're talking about, not necessarily processors, because we can have multiple CPUs on one processor. But in this case, we're talking about one single CPU, one part of, say, if we had a multi-core processor, one single CPU actually pulling that workload faster. Now, the CPU can really only process information and do one thing at a time. Processes in, processes out. And how fast it processes the information is clock speed. So the time it spends in the CPU here is clock speed. When we're doing things that are requiring a lot of CPU usage, we don't really want to have any time where our CPU is just sitting here idle. Anytime it's sitting here not thinking is wasted time for our CPU. We're going to notice issues, or we're going to notice slowness in processing our applications. So what can we do in order to maximize the most out of this CPU so it doesn't just sit here and waste time? Well, we want to make sure that there's always tasks ready to be accomplished by the CPU. Hyperthreading essentially allows the CPU resources that grab tasks for it to do, to grab tasks and have it ready for the CPU to push through. Sort of like it's almost acting as if there are multiple CPU cores, and it's getting all that information for the CPU cores ready. So we don't have our CPU actually sitting here idle anytime. Now again, hyperthreading, it isn't on all of the CPUs out there, and it's Intel proprietary, so it's only going to be on the Intel CPUs. But when we combine hyperthreading with high clock speeds and multi-core processors, we can actually take each single CPU in our multi-core processors by using hyperthreading, that we're constantly having tasks available and that we're grabbing those. Now, not all tasks on our computer can really have hyperthreading be beneficial to them. say if we have a task that we can't really grab more information, there's no waiting time between the CPU, it's constantly processing, then it doesn't really help us too much. But if in situations where hyperthreading is very useful, is say in video editing or multitasking several different tasks at the same time, or 3D rendering, all of those things actually have a lot of different chunks that our CPU could be processing. Say, for example, like in video editing, the CPU knows where that video is going to go. It already knows that video memory is traveling in the same logical direction. So it doesn't need to spend time spooling up that video. It needs to use its tasks making other calculations. So while one side of the CPU is just still spooling the video, the other side, the CPU can actually be grabbing those tasks, those calculations it needs to make for the video editing, and queuing those up and processing those through while it's actually doing other tasks as well. So as we can see, hyperthreading is it's a big step up. It really helps us out when we want to make sure that we're getting the most out of our CPU and that we don't really waste any time or waste any resources that it has.